Hey everybody, this is the second part of lesson 4-6. One of my kids called right in the middle of the video and stopped it, so I'm sorry about the abrupt ending. But let's pick up where we left off. So I can now prove that that angle A is congruent to angle D by, and this is so simple, by corresponding parts of congruent triangles are congruent. I proved the two triangles congruent. Now I can prove any parts of them congruent using CP/CTC. All right, we are going to move to the other side of the room. Sorry for the weirdness of that, but we've got to use the other board now. And I'm going to move this chair out of our way. Y'all are so patient with these very unprofessional videos, but they do help us to get our material in. So let's run through this proof. We've got two more. Okay, this time we need to prove that PQ is congruent to PS. That's right here, PQ and PS. Our given was that PR bisects the angle on this side and the big angle on this side. So you can tell that I labeled both of those, and I start my work from there. So I'm going to say that, let's see, angle QPR, this one right here, is congruent to SPR based on the definition of a bisector. If it bisected the angle on that end, then it cut it in half. The same thing is true for the angles on the other end. The top one is congruent to the bottom one by definition of a bisector. Those are two angles that I have figured out for this proof now. The last thing I'm going to do is look for a way to prove these two triangles congruent so that I can ultimately use CP/CTC to prove what they want me to prove. So, sorry, it's so hard to get that quite right. All right, so what I see is that there's a side in between those angles. So I can say PR is congruent to PR, and I'm not putting my line segment signs for the sake of time, by reflexive, and I'm not going to write the whole word. I'm going to abbreviate because I'm almost out of time. So I have side, angle, side. I've proven those triangles congruent by side, angle, side. So now I can do what they asked, and I can say PQ is congruent to PS right here by corresponding parts of congruent triangles are congruent. So I proved the two triangles congruent, and then I knew that I could say that any other corresponding parts had to be congruent because the whole triangles were congruent. All right, last one before my next class comes in, and I will warn you that I have the door closed, but it's possible that they will just walk in anyway. So if it gets loud, you bear with me and try to stay with me on this proof. All right, the last one, prove that ED is parallel to GF. So we want to prove this top line is parallel to the bottom line. This one's going to be a little bit more complicated than our previous proofs, so bear with me. What we're given is that EG is parallel to DF. We're also given that the same line segment, EG, is congruent to DF. So let's go from there. That gave us one of our sides that those are congruent. I can now say, okay, what do I remember about parallel lines? They told me they were parallel for a reason, so what do I need to do with that? I'm going to use that for alternate interior angles. I'm going to say angle EGD is congruent to angle F. No, that is not what I meant to do, and I know y'all know that. That was supposed to be this angle. I'm so sorry. FDG, and that is by alternate interior angles. Okay, so now we have an angle. Is there a side? We have a side and an angle. I could prove these two triangles congruent easily with side, angle, side, so let's see if there's a side. Look for a reflexive side. Side GD, I know you can hear my students in the hallway being loud, is congruent to side GD, and that is reflexive. I know that you are familiar with that one and comfortable with that one. Just make sure you've got that word memorized. And now I can prove, and I do not have time to say which triangles they are, but this triangle is congruent to this triangle by side, angle, side. Now, what did they ask me to prove? They asked me to prove that this is parallel to this. How am I going to do that? I've got to have another piece of information. One thing that I can do is, because now that I know that the triangles are congruent, I can use the CP/CTC, and I'm going to do this. I'm going to say I know that this angle, FGD, is congruent to this angle, EDG, FGD, EDG, by CP/CT, and the reason that helps me is because of the converse of alternate interior angles. If I know that those two are congruent, then that shows me that this line is parallel to this line, because remember what the converse says? It says if you have two lines crossed by a transversal and their alternate interior angles are congruent, then the lines have to be parallel. Let's look at that. This is a line and a line. Looks like this, crossed by this transversal, and this angle is congruent to this angle, right there and right there. Then the lines have to be parallel. So I was able to say those are congruent by CP/CTC, and then because they were congruent, I was able to use the converse of the alternate interior angles theorem to say that the parts were parallel. All right, that is it. Remember, we're not going to do the last part of that lesson. Sorry about the abrupt ending in the first video, and I will look forward to seeing you next week.